So in this case, we are going to have a continuation, simplifying our algebraic expressions. And also sometimes we need to also to remember our algebraic part of factorization as we are to simplify, and also the consideration of our exponents. This is the major important part that you have in your algebra. As the part of algebra, we have it. We also consider some of the laws of exponents in the simplification. All right, so there we are given simplify. Question number 1 that we are going to consider in this class. What are we supposed to do? We are given in this case. All right, let me just try here this way. So we are given this particular question on question number 1, that is minus 12 a to the exponent of 3 b squared c, everything being divided by negative 8 ab to the exponent of 7 cd, like this. All right, so this is what you're given to simplify. There are so many ways that we can have this in the understanding. All right, what we simply have here is that when you are given, let's say, a to the exponent of 3, like what we have in this case, what does it mean? It means that I'm having a times a times a 3 times. That is, there are 3 a's here. So if I understand this, that these 3 a's that I'm having here, they are being divided by only a single a that is in the denominator. This gives me the advantage to cancel this a with one of these 3 a's that are given on top, so that we are remaining with only 2 a's. If they were 3, they were written as a to the exponent of 3. So if they are 2, how are we going to write it? We are going to write it as a to the exponent of 2. So if I understand this, it can be a greater advantage that I just need to cancel this. All right, let's start with this part. We are to simplify here. Negative and negative, these two will cancel. Let's move on to the numbers. There is a 12, there is a 4, there is an 8 here. And between these two numbers, 8 and 12, there is a highest common factor between these two numbers, which is a 4. So we can divide by 4, that is 12 divided by 4, which is going to give us a 3. 8 divided by 4, that is going to give us a 2. So in terms of the numbers, there is a 3. In terms of the numbers, there is a 2. Okay, let's move on to the A. Like I was saying, if you see this, consider, you can see, okay, there are 3 A's here. Here there's only 1 A. So if I divide this 1A into these A's, which are 3, how many will remain? If they are 3 and I just divide by 1, they are going to remain with only, or we are going to remain with 2 A's there. There were 3 of them. The same thing here. There are 2 B's here. That is B squared. There are 2 of them. Here there are 7. So if we cancel these ones that are smaller, we can, because there are many, 7. Here there are 2. So if we cancel these 2 into these ones, which are 7, there are 7 B's there. So we cancel only 2 from those 7. How many will remain? There were 7. We removed 2. How many will remain? Only 5. We are going to remain with 5 B's. The same thing, there is a C and there's just 1, and this is, they can cancel 1 and 1. That is a 1. The D, there's nothing to cancel with the D, so it's just going to remain as it is. So this gives you the advantage to multiply the numerators. Everything that is remaining on the numerators, 3 times a squared times a 1. So this will be 3a squared. Everything over what? 2 times b to the exponent of 5. That's it. So using this concept, you can simplify direct. You can simplify direct. So let's see. We are going to understand each other. There's so many ways we're going to have this exercise in many ways, but I just hope you understand what I'm trying to explain. For number 2, we are given minus 5m to the exponent of 3, n to the exponent of 4, everything being raised to the exponent of 2 over minus 5m n squared, everything being raised to the exponent of a 2. And you're being asked to simplify this. So the question is, what am I supposed to simplify and how? It follows that whenever, remember the concept of a negative number being raised, just a negative being raised to an even exponent, or a negative being raised to an odd. Let's say I've got a negative there, a negative. So if you raise a negative to an even, it becomes a positive. If you raise a negative to an odd number, it remains as a negative number. The even numbers, we're talking about 2, 4, 6, 8. Remember your even numbers. The odd numbers, when you divide by 2, you get a remainder of 1. We're talking about 1, 3, 5, 7, 9. Those are odd numbers. If you divide, if you raise to an exponent of an odd, it remains as a negative. So this part is very, very important because we see it applying here, a negative being raised to the exponent of 2, which is being an even number. It means it is going to be a positive. So this is going to be a positive. So guys, positive, just leave it like that. But know that it's a positive. So you move on now. There are terms, numbers inside, and also these terms inside being raised to the exponent of 2. So it follows that each and every part is going to be raised to the exponent of 2. Everything. So as I said, the negative is being raised to the exponent of negative 2. All right, so you can even write it like this: minus 5 to the exponent of 2. M to the exponent of 3 to the exponent of 2. N to the exponent of 4 to the exponent. Everything will be raised to the exponent of 2. Okay. In the denominator, we are going to see that the negative 5 that we're having is out of the bracket. It is not inside this bracket. So this 2 is not affecting this 5, negative 5. No, it is just going to remain as a negative 5. It is the m that is going to be affected with an exponent of 2, just like what happened on this part. So the m is going to be raised to the exponent of 2. The n squared is going to be also raised to the exponent of 2, that is outside. So by doing this, we understand that x, when being raised to the exponent of m and to the exponent of n, there's an exponent and there's also another exponent. These two, they can be multiplied together. They can be combined together. So remember your exponents, all right, from a term 1. That part is now into application. So these two can be multiplied. So meaning to say, we can simplify this. All right, let us simplify the first part. So we have got a negative 5 being raised to the exponent of 2. Like I explained, negative is going to be a positive. So 5 squared, that means 5 times a 5. That's 5 squared, which is going to give us a 25. So meaning to say this will be a 25 m to the exponent of 3 to the exponent of a 2. We are back on this one. So we must multiply m times n. That is 3 times 2. And 3 times 2, that is a 6. The same thing, 4 times 2 on n, that is to the exponent of 8. Everything over negative 5 m squared. So this, there is a 1 there. There is a 1. So you're multiplying 1 times 2, just like what we had on this part, m times n. So it's 1 times 2, which is going to be m squared. The same thing, 2 times 2, that is going to be n to the exponent of 4. We are back to that stage that I was explaining, that if you understand the concept that how many m's, how many n's that we have that can cancel, all right, we can use that concept. This is negative 5 into 25. Like, How many times? 5 into 25, or 25 divided by 5. Let's say 5, but there's a negative there. So it's going to be minus 5. Okay, let's consider that m. There are 2 of them here. Here there are 6 of them. So if we divide these 2 into these ones, which are many, which are their both, there are many here, 6 of them. So if we cancel or we divide these ones, divided by this, how many will remain here on these ones, which are many, if we just remove 2 of them, because they were 6, and we just remove 2, how many will remain? We are going to remain with the 4 m's. So that is 4 to the exponent, m to the exponent of 4. The same thing on these n. They are 8 here, here they are 4. So if we cancel these ones, 4 into these ones, which are 8, how many will remain? 8 minus 4, meaning to say we are going to remain with 4 of them. So that is n to the exponent of 4. So you see that even the application of your exponents can be used, the laws of exponents. Remember from our laws of exponents, x, when being raised to the exponent of a divided to x to the exponent of b is x to the exponent of a minus b. We are dividing, we subtract. So you can also use your laws of exponents. It is the same situation that you have, or same application. So they are going to ask questions typically on these laws and those basics that you understand from your algebraic expressions. Like if you check on number 3, where we are actually, on this case, we need to factorize. There is an expression added to another, a term added to another term, making an expression divided to 2ab. So in this case, you are going to see that we cannot add these 2 terms. They are not like terms. But what we can do in the numerator on top here is to factorize. Remember, we are dealing with the binomial, 2 terms. Whenever there are 2 terms, first thing that you think of is to factorize. Finding of the highest common factor between these 2 terms. You factor out that highest common factor. So the question is, between 4 and 8, what is the highest common factor? The largest number that you can factor out between 4 and an 8. Which number can we factor out? So the question is, what is that HCF? So you see now you back to those, that part of your grade 8. So I think these are simpler numbers that you can check, 4 and 8. The bigger number that you can factor out, that's a 4. All right. In actual sense, you were supposed to have it this way. Remember from that HCF concept, the factors, which are the prime factors of 4. If you have to consider 4, guys, we just have a 2. All right, depends with the way that you're going to write it. Someone can have it this way. The factors is going to be 4. 2 there, 4 divided by 2. That is going to give us a 2. Then we do again by 2. 2 divided by 2, that's a 1. There's no need for us to write this. All right, so there is a 2 and a 2 there. If you do the same thing on this 8, if we divide by 2, that is 8 divided by 2, what are you going to have? That's a 4. We divide again by 2. 4 divided by 2, that's a 2. All right, then again by 2. 2 divided by 2, that's a 1. All right. So, okay, guys, you see what I'm right? Where am I writing this one? All right, so that's a 1 there. So meaning to say that 8 is 2 times 2. So I said you can even take this way. Like this is 2 times 2 times 2. So if you have to consider now for the highest common factor, you just consider, all right, 2 is common. There's a 2 here, which is the same as this 2. So you're taking these 2 and this 2. All right, there's these 2 and there's these 2. So this 2 is no longer correct. There's nothing corresponding here. So it is just 2 and 2, 2 and 2. So it's a pair of 2, a pair of 2. All right, so that's 2 times 2, which is 4. So that's your highest common factor in terms of the numbers. We're going to factor 4. Then in terms of the letters, you take the 1 that is common and must have the smallest exponent. So which one is common? A is common. There's A here. There's also A, but which one has got the smallest exponent? That is A. Then B is the same. So it's going to be B squared. B squared and B squared is just one and the same thing. So that is your highest common factor on everything. So let's factor out. This is going to divide to this one. What you factored out for A to the exponent of 3B squared over what you factored out for AB squared. So this will cancel, this will cancel. They are the same. So the question is there's only one. Here there are 3 of them. So it will be A squared. So there we're going to remain with A squared. We do the same thing on this 8. We're going to have the same thing. This divided to this. So that means we've got 8AB squared over what? Over 4AB squared. So the A and the A are the same. The B squared and the B squared are the same. So 4 into 8 is 2 times. So that is going to be A squared plus 2. Everything over what? Over 2A plus, over 2AB in the denominator. So that's it. Once you've factored out, you have got the ability or the power to divide these terms outside because it's a product that you have. So this can be divided to this. We have the power to do that now. So that's 2 into 2, that's 1. Into 4, that's a 2. 4 divided by 2, that's a 2. The A and the A are the same. So remember, if they're the same, they can cancel out. B, there's only one B here. There are 2 of them. So if we cancel here, we are going to remain with 1B on top. So as you can see, there's nothing left in the numerator, in the denominator, just like 1. So in the numerator, you are left with 2B into the bracket of A squared plus 2 divided by 1. If you divide by 1, that means there's nothing there. It's just like 2 over 1. 2 over 1 is right. It's 2. So dividing by 1 means to just write that term or that expression as it is. So you see how the factorization plays a role, the HCF concept. You have to use your factorization where it is applicable. Just like number 4, we are given also a situation where we need to apply our factorization in this case. So this is 3x squared minus 12x. So if you have to consider, all right, I can see, okay, there is a 3 there. In the numerator, is there anything common? 3 is common. That's the highest common factor. So you're going to factor out 3x. So let's divide 3x squared divided to this 3x. What are we going to have at the end? If we divide by 3x, this will cancel x. There are 2 of them. We remain with only 1x. The minus 12x, it also divides to the 3x. So if you had to do this x and x cancels. 3 into 12, that's a minus 4. So that means we're going to have a minus 4 everything over what? We are dividing everything to 3x. So you're having 3x and 3x that are the same. They can cancel each other. The 3 and 3, that's a 1 there. So meaning say we're just left with x minus 4. That is the case. We're just left with this. You have to be very, very careful in your simplification. How to factorize? Are you able to notice the factorization that you're given there? Are you able to do that? You are supposed to be able to notice the factorization that you are given. Apply the factorization that you are given. You're supposed to be like that. All right. So there are 2 questions that we are also having. Question number 5, where we are given 9a squared b minus 18a b squared. Everything over minus 3ab. So let's factorize. Between these 2 terms that we are having here, what is the highest common factor between 9 and 18, the bigger number that you can factor out? That is a 9 there. 9 and 9, 18 and 9, that's a 2. Between a squared and a, which one are you going to take? The one with the smaller exponent. That's the highest common factor. So we take A, which is the same thing between B and B squared. We take the one with the smaller exponent, which is a B. So this is what you're going to have as your highest common factor. So let's divide 9 and 9 cancels. A squared and A, that's an A. B and B, it cancels. Minus 18 divided to this 9, that's a 2. The A and the A cancels. B squared and B, there are two B's. We divide to this one B, so we are just going to remain with only a single B. So this whole part is being divided to minus 3AB. Okay, so let's divide. 9 divided by negative 3, that's a negative 3. The A and the A cancels. The B and the B cancels. You remain with the bracket of A minus 2B. Just like that. Just like that. So you have to be very, very careful in your simplification. So this is another question that you're given in this case. All right. That is a to the exponent of 4 plus a to the exponent of 4. This is on number 6. A to the exponent of 4 plus a to the exponent of 4. Everything to the exponent of 4. Everything over the square root of 64. A to the exponent of 8. All right. Times a to the exponent of 8 again. All right. What are they trying to do, these guys? All right. No problem. Let's see. So this is what you're given there. Whenever you have got a question like this, you just have to analyze. So you see, guys, some of the questions you just have to be good in analyzing your question. What is it that I'm supposed to do? Like these two things are the same. It's just like I'm given x plus x. There is a 1, there is a 1. 1 plus 1, that is what? That is 2x. So it's just like I'm given 3x plus 4x. I can add because they are like terms. So this is the same situation that I'm given here. These are like terms. So there's a 1, there's a 1. So we can even add these two before we talk about anything, because they've got a to the power 4, a to the power 4. So these can be added. 1 plus 1, that's a 2. So this is 2a to the exponent of 4 being raised to the exponent of 4 again. All right, this exponent of 4, remember that. So we only added this to be a single term. Everything over what? Which is the same thing on this part here. Okay, which is the same thing. All right, we can determine the square root of 16. The square root of 16, that is a number that multiplies itself to give us 16, which is 8. All right. But then what about the square root of this a to the exponent of 8? Because it can be combined. But what is the square root? We can combine these two, or we can first find their square root. The square root of this, it means there is a 2 there inside of the square root. So to find the square root of an exponent, whenever you're given an exponent, you divide by the number inside of the square root, which is a 2. So that's a to the exponent of 8 divided by 2, that's a 4. So meaning to say, we have got a to the exponent of 4 times the same thing on this a to the exponent of 8. It is going to give us a to the exponent of a 4. So that's if we are given the cube root of a certain exponent, a to the exponent of 9, it's simply a to the exponent of 9 over the number inside of the root sign. So if there's a square root, the square root of a to the exponent of 8, it's a to the exponent of 8 over the number inside of the square root, which is a 2. That's the idea there. All right, so after that, you can simplify this. Okay, let's see. What are we having? Let's start with the 2, a to the exponent of a 4. Remember, I talked about raising a certain bracket to a certain exponent. It means everything is supposed to be affected by that exponent. So it is 2 to the exponent of 4, 2 to the exponent of 4, which is 2 times 2 times 2, 4 times. And that is going to give us a 16. 2 times 2, that's a 4, times 2, 8, times 2, a 16. Or you can use a calculator there. There is a to the exponent of 4 to the exponent of 4 again. So an exponent and exponent, I said you multiply. So it's 4 times 4, which is a 16. All right, everything over 8. This time, it's different situation that you're having here. This time, you're multiplying the bases that are the same, a to the exponent of 4 times a to the exponent of 4. You're multiplying. So what do? You add the exponents. If you're multiplying the bases that are the same, you add the exponent. So that will be a to the exponent of 8. All right, 16 divided by 8, that is going to be 2 times. So this is 2. Remember what I said? There are 8 a's that we have here. Here there are 16 of them. 16. So if we cancel 8 into 16, how many will remain? We'll remain with 12. Or how do we simply, we're going to remain with an 8. We cancel this 16 minus 8, which is going to give us 8. We are dividing the bases that are the same. You can even subtract your exponents. A to the exponent of 16 minus 8. So this is 2a to the exponent of 8. So you see how do they try to play with us? Be careful in your simplification. So each and every part that you're going to be given, it's a simplification that you need. Yes. How to simplify, it's very, very important. So more to come from Meson African motifs till we meet again.